Hi, in this video we are crafting a kick in the EaganMatrix. In the first part, we created the kick itself and explored the use of shape generators. Now that our preset is functional, we'll make some improvements, adding velocity, which will allow us to discuss the structure of the formulas, creating custom controls with macro controllers, and finally, restricting our sound design to a specific zone of the interface using a new feature in the term W. The first improvement we want to make is obviously to add a velocity control for the kick's volume. We want the output volume, which is currently constant, to become proportional to the velocity of our impact on the interface. In the context of the EaganMatrix, this means that formula A, which currently equals W, should be multiplied by Z. W will then become the maximum output value, and Z, representing our velocity, will scale it to a certain percentage. To achieve this, we'll need to adjust the structure of the formula, which means changing the signs between the terms. By clicking on the letter, the menu we need will appear. Let's select a structure where Z is multiplied by W. Then set the second value of Z to 1, and now our formula is scaled from 0 to 100% by the value of Z. If Z equals 1, then A will equal W and produce the maximum value. If Z equals 0.5, then A will equal W divided by 2, halving the output volume. If Z equals 0.1, A will equal W divided by 10, etc. I am showing this only on A, but be sure to make this change on all the output formulas, so here on C as well. The squared curve is still a great fit for this purpose. However, when the velocity is at its minimum, the output volume might now seem too low. We can adjust this by increasing the first value to constrain the kick's volume within the desired amplitude. If Z were the only parameter in the formula, this could be an issue, since the volume would always be greater than 0, and the preset would constantly produce sound. The multiplication avoids this problem. I am deliberately not giving a specific value for Z. From here, it's all about listening and making personal choices. Our kick is now responsive to the power of our gesture. If we want to be able to adjust certain characteristics of our instrument easily and quickly, without diving into the details of the EaganMatrix or even opening the Haken editor, we can program macro controllers. These are rotary knobs found on page C1 of the Haken editor and can also be accessed through the hardware interfaces of our instruments. To set them up, we start by defining them in the text editing area below the matrix. There, you can choose from various appearances and styles based on the intended function of each macro controller, following specific naming conventions. Then, we'll retrieve their values using the term W in the formulas. Macros act like remote controls. If well programmed, they allow for more intuitive sound design and provide faster, more organic access to shaping the character of the instrument. Let's say we want to be able to tune our kick. We have seen that the constant created by the term Y of formula B defines this frequency. Let's set it back to 0 and patch a new formula D to handle this offset function exclusively. In the modifier menu, select times I from 0 to 1 or times macro then times I from 0 to 1 if you are on version 10.40 or higher. The value of macro 1, which is between 0 and 1, will then be multiplied by W, and the output will become a percentage of the maximum value of W. By setting W to 0.1, the macro will vary W between 0 and 0.1, which in this case means between 0 and 100 Hz. Now we need to configure our macro. A graphical or text representation is not ideal for us. Here, we prefer to have access to the frequency. Therefore, we will use the integer list controller from the category called Other, which, as its name suggests, scroll through a list of numbers. We will define a list ranging from 0 to 100. Following the specified format, we need to write I, the controller identifier, equals the name we want to assign it, let's call it tune, _1C, the code for this type of macro, _0, our minimum value, _100, our maximum value. By clicking Done, we close the editor and our macro appears. We can now change the tuning frequency of our kick much more easily. With 6 macrocontrollers, it is possible to modify a preset to a certain extent. In the new versions 10.40 and higher of the EaganMatrix, which were recently released, there has been a major improvement in this area. There are now not just 6, but 90 macrocontrollers. They can be found not only on the term W, but also in X, Y, and Z. The formulas thus become completely flexible. And since each of these controllers is MIDI controllable, it is possible to create user interfaces, whether software or hardware, to transform, distort, and tweak a single preset as much as possible. These higher layers of control, which Haken Audio calls overlays, make it possible to control the EaganMatrix with interfaces that are more in line with the conventions of the synthesis world. If this topic interests you, I recommend checking out Ed Egan's explanations on the subject at ContinueCon 2024. I put the link in the description, as well as the latest videos by Richard Cram showcasing this new tool. As for me, I'll be presenting my own overlays as soon as possible. A final improvement we could make to our kick would be to localize it within a specific zone to leave room for other sounds. To do this, we will explore a new feature of the term W. Below its editing area, you can select 2 notes and their octaves, which will set the boundaries within which W will be active. Outside of these limits, W equals 0. If multiplied by the rest of the formula, it will act as a sort of switch that is on within the range and off outside of it, since 0 multiplied by anything equals 0. By default, it's active between C and B across all octaves, meaning it is always active. Our output formulas, A and C, already have an appropriate structure. By setting the active range of W between C0 and B3, our kick, while unchanged in its sound design, will only be present to the left of our instrument. For reference, C5 in the Haken editor is 261 Hz and corresponds by default to the middle C key. Personally, I use an even more restricted distribution where the kick, snare and hi-hat are grouped within less than an octave, allowing for finger drumming with my left hand while playing other sounds with my right hand. By combining classic synthesis and additive resynthesis with Loris Synth, the tool developed by Christophe Duquesne for the EaganMatrix, I can create rich drum sounds with unique playing possibilities. My first overlay, Batterie, will be dedicated to this use and will enable the intuitive creation of very distinctive drum kits, suited for playing on the Continuum or Osmose. To get an idea, you can listen at my Sound Advent calendar, whose drums I created with a prototype of this overlay. And you are listening to one of those drum kits right now. This concludes the series on creating a kick in the EaganMatrix. I hope you enjoyed it, found my explanations clear and learned something new. I'm uploading the preset created in this tutorial to the patch storage site. You'll find the link in description. I have added a few enhancements as well. Take a look at it, you might learn even more. Thanks for watching, merci et à bientôt.